It is my pleasure to say a few words at the beginning and welcome our guest today. We are about to embark on a three-part forum series on climate change, following up from a series we had several years ago. We're calling it Update on the Earth. I'm Pastor Dan, for those of you I may not know, and I welcome all of you here today. Our forums last an hour, so just after about 11 a.m. this morning, we'll conclude the discussion. We record the forums and post them on our YouTube channel. That's Queen Anne Lutheran Church YouTube channel. So if you would like to go back and review material or want to encourage others to see the video, we invite you to do so accordingly. As I said, today is the first of three session series we're calling Update on the Earth. Our next session will be not next Sunday, that's Memorial Day weekend, but June 6th when Dr. Ebi will join us again, and then June 13th where we'll talk about next steps. What can we do as individuals and as a faith community to follow up on this update? Our liturgy as well will reflect the theme of God's care for creation. You'll notice that the sermons and the hymnody have been chosen to reflect this theme. We're going this time to be looking at the role we play as stewards of God's creation, but we want to do it starting with a scientific perspective to inform our efforts and our understanding. And so it was with that in mind that I'm delighted to welcome back our guest speaker, Dr. Kristie Ebi, who is going to talk about this issue. She is a professor of public health at the University of Washington and a major contributor, I believe, to the Intergovernmental Panel on Climate Change, which is how I first learned about her on the front page of the Seattle Times. Again, we're so delighted to have her with us, and we look forward to the conversation. Dr. Ebi?
Thank you. Thank you so much. I really appreciate all your interest. And being a scientist, of course, I'm going to have slides. So that will really help me anyway in talking through issues, and hopefully the visuals will be helpful for you as well. And I wanted to start with the broader context that there is under the United Nations the 2030 Agenda for Sustainable Development. This was signed the same year as the Paris Agreement, and it's a plan of action for people, planet, and prosperity. It was signed essentially by all countries in 2015. It aims to strengthen universal peace. It recognizes that eradicating poverty is the biggest challenge that we face, and it's critical for reaching all of the goals I'll show you in a moment. There are 17 Sustainable Development Goals called SDGs, and this is the summary of those goals. So all countries are working to achieve these goals. There's lots of work being done on research and on providing the methods, the tools, the human and financial resources that countries need to be able to achieve each one of these goals. You can see that goal 13 is climate action. So climate action sits within this context, that when we think about the risks of a changing climate, what we need to do about that, we have to take into account all of the other changes that are going on and make sure that when we take action to address a changing climate, we don't harm health, we don't harm life below water, for example. And I'll mention some of these as I go on, but wanted to start with the broader context. I also wanted to take a moment to talk about the United Nations Framework Convention on Climate Change, or the UNFCCC. And you can see the timeline on the left, that there was a World Climate Conference in 1979 that eventually led to the forming of the UNFCCC in 1992. But in the meantime, the Intergovernmental Panel on Climate Change was formed jointly between the World Meteorological Organization and the United Nations Environment Program. And those two UN organizations formed the Intergovernmental Panel on Climate Change to inform the negotiations that were ongoing at that time for what became the UNFCCC. And this was planned to be a one-off. There was supposed to be one report, was released in 1990. And this led to another World Climate Conference that fed into the Rio Convention that led to the UNFCCC. All countries in the world have signed this convention. Later this year, you'll hear quite a bit about what's called the Conference of the Parties. And this is Conference to the Parties of the UNFCCC. This is an intergovernmental agreement. When a country signs that agreement, it becomes a party to the agreement. And so what happens, hopefully in Glasgow, well, it's going to be in Glasgow. We're hoping it's going to be at least partially in person. So later this year, in November in Glasgow, there'll be another annual meeting of the parties to the UNFCCC. It's called the Conference of the Parties or the COP. So when you see information about that, that's what it refers to. A little later in the talk, I'm going to come back to this point. The convention is written in very standard UN style. There's a series of articles. And Article 2 gives the ultimate objective of the convention, which is stabilization of greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. This is a convention that was signed, as I said, by the world governments. It was negotiated by the world governments. And so this is negotiated text. All of the world governments have agreed to this text. And I'll talk a little bit later about how, as scientists, we've been grappling with understanding how you define dangerous. That dangerous is not a scientific term, and we all view danger differently. There's people who go out and do bungee jumping and think that's perfectly safe. People who go out and do skydiving and think that's perfectly safe with appropriate controls, for example. But other people would not view that those safe activities. So that's been an area where there's been quite a bit of science going on that we'll talk about. So basically, the convention can be summed up in these three bullets. That climate change is an urgent and potentially irreversible impact on people, on our ecosystems, on all of our activities. We know that deep reductions are required. And I can tell you from working with negotiators over many years, the negotiators absolutely recognize the urgency in addressing climate change. Trying to get 195 people, 195 countries to agree on anything is a challenge. They are making progress, and there's lots written, of course, that the progress is not as fast as it should be. And with that, I wanted to spend a moment then on the Intergovernmental Panel on Climate Change, or the IPCC. As I mentioned, it was formed between the United Nations Environment Program and the World Meteorological Program. And the IPCC is a intergovernmental body that is designed to oversee assessments. The IPCC itself does not conduct research. It does not monitor trends, but it does oversee comprehensive assessments. Right now, the 6th assessment cycle is ongoing. Later this summer, the working group that focuses on the climate of the science of climate change will release its report after an approval session. The IPCC assessments are mandated to be policy relevant while being policy neutral. Those of us engaged as scientists in these assessment reports can tell governments the consequences of actions, but we can't tell governments what to do. We're scientists, but we can present the science behind it. Review is essential, and I'll go into quite a bit of detail on the review. And it's mandated to include differing viewpoints within the literature to make sure that the assessments accurately reflect the range of opinions in the scientific literature. And just like with the UNFCCC, the IPCC is composed of government. That as a scientist, I am not a member of the IPCC. I can be called upon by the IPCC to engage in assessments, and I've been involved in many assessments, very fortunate to be involved in those assessments. But it's the governments who decide when there's going to be an assessment. And there's a lot of detail in here about how the whole process works. And it's governments get together, make decisions, decide when there should be assessments. And there is a very strong science policy interface throughout an IPCC assessment. The outlines are proposed by groups of scientists, and then the governments go through a line-by-line approval of those outlines to make sure that those outlines reflect the kinds of questions they would like to have answered. There's mandates about the author teams. The author teams have to have not only the scientific expertise they need, but they need to be balanced in terms of geography and in terms of gender. Again, I'll talk about the review process in a minute. And at the end of an assessment process, there is a plenary where the summary for policymakers, which is a very short synthesis of an assessment report, is literally approved line by line, word by word by the governments. So you're sitting in a hall with hundreds of people, there's 2 large screens, and the summary for policymaker goes up, and they go through each sentence. And it's by consensus. Every government has to sign off on every sentence. And governments have lots of different opinions. It takes a long time. Typically, it takes a week to go through a summary for policymakers. A document that's about 20, 25 pages long. And everybody gets to express their opinion. The scientists are there to make sure that no changes are in violation of what we know from the scientific literature. And in the end, the summary for policymakers are then used by governments in their countries to help set policy. And this is the structure of this. I just put this in because it reinforces that the IPCC is government. And there's 3 working groups. As I mentioned, working group 1 looks at the physical science basis for climate change. And that will come out sometime this summer, I believe in July. I've worked in working group 2, which looks at the impacts of climate change and adaptation to those impacts. And that will come out early next year. Working group 3 looks on mitigation. Across these 3 reports, there are hundreds of scientists engaged. Thousands of pieces of literature are assessed. And there's a very robust review process, which is central to the process. This is an overall schematic of showing how the different pieces fit together. I also want to point out on this slide that expert reviewers, as I said, the review process is critical, that thousands of scientists volunteer their time to go through each chapter and provide comments on, was all the literature captured? Was it captured accurately? Are there any other points that should be raised? And this is an outline of how this looks. I've got some text on the right-hand side that was for a special report that came out in 2018 on the impacts of warming of 1.5 degrees. And so it just shows you as we go around the cycle of this very detailed review process. In the special report on global warming of 1.5 degrees, there were just 7 chapters. I haven't looked at it today. I think it was just 7 chapters. There were 1,113 expert reviewers. And in total, there was over 42,000 comments. It's required by the IPCC that each and every comment have a written response. I was in chapter 3. Our chapter alone had 11,500 review comments. And we had to address each one. It doesn't mean you make the change that's recommended, but you have to look at each comment, assess whether it's consistent with the underlying literature, whether it improves the assessment, whether it brings in viewpoints we somehow managed to miss, or whether it's a comment that really is inconsistent with the science. So you have to go through and work on each one of these. And this is one of the reasons why these reports take a couple of years. It's quite a long process. There's a common misperception in the media that the authors, there's also review editors, and the reviewers are all volunteers. They're not paid anything to do these reports. When I led part of the 5th assessment report, we estimated that for each chapter, there's a coordinating lead author. We estimated over the 2.5 years that they would spend about 6 to 9 months of their time working on the report. The lead authors, 4 to 6 months, review editors, about 3 months. It's just amazing that people continue to put their names forward to be able to do this. It's a significant effort, and yet it is so important. And these reports then go back to the UNFCCC and inform the negotiations. It was hugely gratifying at the end of the approval of the Paris Agreement. Every country was able to make, and most countries made, interventions. And several countries explicitly thanked the scientific community and said we wouldn't be here without the scientific community and all the time that they volunteered on their reports to understand the risks and what can be done about them. So the IPCC has contributed significantly to climate science and to policymaking. This is one of their graphics they put together to show that. And with that, I was going to stop for a couple of minutes here and take some questions before I move on to something that's being used in the IPCC to help synthesize our understanding of the risks of a changing climate. And you can either put something in the chat, although at the moment I can't see the chat, or you can raise your hands if you know how to do that. I've got to figure out where the chat is. Oh, there's a chat.
If you want to, just for the moment, can you turn screen share off?
Sure.
There we go. Yeah.
I know that was fairly bureaucratic, but sometimes it's useful to understand the bureaucracy of how these things work to get a sense of what goes on behind the production of a report and then how it's used. Does anybody have any questions on that? Not, I'm happy to go.
Yeah, Meg, go ahead.
I'm just amazed that it's volunteer hours. I mean, that's kind of unfathomable.
Each working group has a technical support unit, and that technical support unit is paid for by whatever government supports the technical support unit. But everybody else is a volunteer.
I've noticed that one of the dominant talking points against the fact that we're contributing to climate change seems to be that people will say the scientific community lacks consensus. And they might even point to the number of reviewers, for example, that you've mentioned. How do you respond to that? Do you hear that criticism often? And if so, what's your quick response?
We're scientists. There's been a bunch of studies. So there was a recent study looking across the scientific community, and 97%, 98% of scientists agree that the climate is changing and the cause is us. And you start thinking about, boy, when I was growing up, there was these advertisements of 4 of 5 dentists agree for something. It's just like, it's basically everybody. There's always contrarians. There's always people who have somewhat different perspectives, and that's how science advances. We need to have that. Mm-hmm. But the consensus is incredibly strong. And what's happened is there are skeptics. As scientists, we all are skeptics, and I shouldn't call them skeptics. But there's contrarians. And they occasionally publish pieces of, we talked to 2,000 scientists who don't agree. And when you look at those 2,000 scientists, turns out podiatrists are pretty happy to sign on to claims that climate change is not a big issue. I shouldn't pick on podiatrists, but I can't figure out why they would sign those kinds of petitions. The evidence is incredibly strong. The evidence could not be stronger, and unfortunately could not be stronger. It's that the climate is changing so significantly, so rapidly. There's no question that climate is changing, and there's no question that humans are causing it.
Right. Thank you. Looks like there's a question in the chat.
That's a good question. I can talk about that more next time if you would like me to. So COVID-19, in terms of climate change worldwide, there's been about a 5% reduction in greenhouse gas emissions, at least during about April and May of last year. But those emissions are coming back to where they were before. In terms of the process, everything has been quite delayed for the IPCC. That a couple of things, we have 4 lead author meetings where we get together. We had a lead author meeting at the end of January, beginning of February, a year ago in Portugal. And then everything just fell apart. We had authors with COVID. A lot of the authors are academics that are trying to teach. Everyone is finding that teaching with COVID is taking us a lot more time. People haven't had as much time to work on it. It's been a really significant challenge to get the report back on track. And they are back on track, and they will be coming out, but not when they originally planned. And I'm on the health chapter for the report that'll come out next year. And as you can imagine, almost everybody in the health chapter has been working on COVID. So the health chapter has been, people are working 110% of their time on COVID. And this is always a volunteer activity anyway. It's been a challenge. Are there any other questions? We'll move on to something somewhat more colorful, if that's okay. Susan?
Yeah. Did the United States withdrawal from the Paris Accord have any effect on this process?
No. It's a pretty interesting question. When the Paris Agreement was signed, as part of it, they put in a clause about countries being able to withdraw from the agreement after they've signed it. And one could spend some time speculating on why. The process was, if you want to withdraw, you put in a notice that you want to withdraw, but it takes 4 years. And so I don't know many other countries that have a 4-year election cycle, but they put it in. I don't know how it happened. I don't know exactly why it happened. But the notice was put in under the last administration. Of course, the first thing that President Biden did was put the U.S. back into the Paris Agreement. So it didn't have much impact. It had an impact on our standing as a nation in the world. It had an impact on countries' ability to trust the United States to follow through on agreements. It had lots of impacts. But the climate change one, I think we can get through fairly quickly. And then, Lisa, did you have your hand up? Somebody else had their hand up.
Sorry, I was just commenting that that was my 4 fingers to show 4 years. I just thought it was ironic that it was, clearly designed to address the U.S.
Yeah. George? You're still on mute. There you go.
Okay, are we unmuted?
Yes.
In addition to the governments, who are the major reviewers? For example, UN development programs or other reviewers about policy implications?
That's a good question. The reviewers are anyone with expertise, and that's pretty loosely defined. So there are 2 official rounds of review. The first round of review is the scientific community. And anyone with some expertise can sign up to be a reviewer. And so you get reviewers from industry, You get reviewers from academia, from non-governmental organizations, from UN organizations. So you get a broad range of representation for the reviewers. The second round of reviewers, when you get the next draft, it goes back to the reviewers who are reviewed the first time, and it goes to all the world governments. So specifically in the United States, when it's the time for the government review, it comes in to the US Global Change Research Program, and which is a mechanism to help coordinate the 13 federal agencies working on climate change. And then it goes out to scientists all across the government. And I was asked by the US Global Change Research Program if I would review part of one of the other reports. So they also reach out to the scientific community. So there's a very broad outreach. There's no way to know for the government review how many government reviewers there were, because all of the review comments go in as the government of the United States of America. But dozens easily would review reports. And all of the comments are put together, and then there's a committee that goes through all of those comments and collates them so that you've got one set of comments and not 5 people saying the same thing. It's quite a process, and other big countries do the same.
I have to say, all that review makes you feel pretty confident about the information. I can't imagine anything else that's reviewed that much.
Yeah. And every now and then you read some contrarian saying this is not peer reviewed, and you think, wow. I publish academically. Typically you get 2 or 3 reviewers. I do not get 11,000 review comments on something from hundreds of reviewers. It's really extensively reviewed. And it's a lot of work for the authors. When I was it was the 4th assessment cycle, I was on the human health chapter. And I had a paragraph where I'd synthesized all the information about what climate change could do in terms of the geographic range, seasonality, intensity of transmission of malaria. And I had 50 or 60 comments on that one. It was just one paragraph, 50 or 60 comments. They ranged from, this is the best summary I've ever read, to, I don't understand this. And you have to clarify it. I don't understand. And then everything in between. So you have to, you understand that the audience is the government negotiators and really are trying to write for those people. We're not writing for our academic peers. And we do get a lot of comments on how to clarify our writing, be more succinct, be much clearer and crisp in how we phrase things. All right, I'm going to move on to something that's a little bit different. What happened to my slides? So I mentioned Article 2 of the Convention is to prevent dangerous anthropogenic interference with the climate system. In the 3rd assessment report of the IPCC, which came out in 2001, there's a chapter that really took this on to say, how do we think about dangerous? And they broke this apart into 2 key aspects. What are the key vulnerabilities of our societies, for our health, for our ecosystems? And then how do we decide what is a key risk to determine what could cause dangerous? And so on the right, you can see its magnitude, its probability of significant risks, irreversibility and persistence, and limited ability to manage. So there's a massive literature review, huge amount of work. And what the authors put together are what are called reasons for concern. And these are reasons for concern for dangerous anthropogenic interference with the climate system. You can see the first one is risk to unique and threatened systems. For example, here in the US, we've got cloud forests in the Southwest that are not going to survive. They're considered to be functionally extinct. That as you looking at ecosystems moving up into altitudes, if they're already high, there's nowhere for them to go. You may have seen pictures of pika. They're this adorable little rodent that lives up at the tree line in many areas in California, Colorado, for example. And some of them have gone extinct. They just can't go any higher. And their physiology is such they can't tolerate the warmer temperatures. Risk associated with extreme weather and climate events. I don't think I need to cover that. We've had more than enough weather and climate events in the last year. The distribution of impacts. We can start thinking about, for example, the impacts on small island developing states, the impacts in coastal zones, risks associated with the global aggregate impacts. What happens when we add it all up? What does the picture look like? And finally, risks associated with large-scale singular events. And these are things like melting of the West Antarctic ice sheet. And then what happened is for each of these reasons for concern, the authors put together a summary figure, and I'll go through this in a little bit of detail. And it's what you see in the middle. And when you look at the figure on the left, it's reason for concern 1, unique and threatened systems. The 0 is pre-industrial temperatures. The gray bar is how much the Earth is warmed today. It's warmed about 1 degree Celsius. And then as you look up the y-axis, you can see that the temperature from pre-industrial to 1 to 1.5 to 2. The colors are important. When the color is white, it means that scientifically we haven't been able to tell if there's been a change in that particular system. It doesn't mean there hasn't been a change in the system. We may not have enough data. There may be no change in the system, but we just can't tell if the system has changed. When the color turns to yellow, it means the system has changed, and we can attribute at least some of that change to climate change. So we know climate change is affecting the system. When the color changed to red, it means the risks are severe and widespread. And when it changed to purple, it is very high risk. Because of the visual of this figure of going from white to yellow to red to purple, these are called the burning embers, because that's a little bit what they look like. So there's quite a lot of work that's been done on the burning embers. They've come out in all of the IPCC reports since the third assessment report. And I want to go through and show you some information, because these are ways to quickly understand where we are with respect to the risks of a changing climate. I was really impressed in the special report on global warming of 1.5 degrees. I'll show you our burning embers in a few moments. When we presented it to the world governments, there was several hundred focal points there. We had about 130 governments. And they're completely familiar with the burning embers. And they really appreciate these figures because it helps them communicating the risks and what we need to do then to address those risks. It helps move their policy. So these are the reasons for concern from the report on global warming of 1.5 degrees. You can see the 5 reasons for concern. The H is high confidence, the M is medium confidence. And so this can be used, and it has been used to compare with previous burning embers. This is a paper that was published last year, and I'll just go through the unique and threatened systems. The TAR is a third assessment report, came out in about 2001. There's a long story behind the fourth assessment report. The burning embers was published later. Oops, sorry about that. The fifth assessment report came out in about 2007, no, it was later than that. It was 2013 and 2014. Special report on a warming of 1.5 degrees came out in 2018. And you can immediately see that over the course of a pretty brief period of time in terms of scientific research, so from 2001 to 2018, you can see that as climate has continued to change and as we've conducted more research, you can see that the risks are coming closer in terms of temperature change and more severe. And you can see that across the three sets of reasons for concern on this slide and the last two on this slide. And so this is part of the message that the IPCC has been sending about the urgency of a change in climate, that it's really urgent because each time we do these assessments, the risks look greater than they did in the previous assessment. And as I said, closer in time in terms of the amount of warming. And over time, there's been improvements in the burning embers. This is from the fifth assessment report, came out in 2017. And so you can see from the little icons, you can see in reasons for concern 1, you've got a little frog here, which is biodiversity. This is Arctic systems. These are coral reefs. And down here, I'm sure our coral reefs are down there as well. I'd have to go back and look at that. This is human health. This is heat waves. And so there's been more specification of what is that reason for concern composed of, and how we need to start thinking then about making a difference in each of those systems. What we did in our chapter was to break apart the reasons for concern into individual systems. So on the left, you see warm water corals. One of the conclusions from our chapter was with another 0.5 degree of warming, from 1 degree to 1.5 degree, 75 to 90% of warm water corals will be gone. At 2 degrees of warming, another 1 degree from today, almost all warm water corals will be gone. You can see also very high risks in the Arctic, small scale, low latitude fisheries. You can see coastal flooding, an issue that we worry about here in Seattle with sea level rise and increasing precipitation. There's lots of maps showing inundation, particularly in South Seattle with climate change. So we're now, with additional literature, being able to construct these embers for individual systems to get a better sense of how severe the issues are. Another modification is there are scenarios. When we talk about climate change, of course, we're looking at the future. The future is inherently uncertain. There are 2 basic sets of scenarios that people are using. One is looking at emissions of greenhouse gases into the future. And another, as separate as possible, is looking at development. And what kind of choices are we going to make as societies, as governments? And how will those choices then affect the interaction with climate change? Because the impacts of climate change will really depend on where we put cities, what our cities look like, what our urbanization looks like, how we're going to invest in biodiversity, for example. This is from the special report on climate change on land and shows you for desertification, land degradation, and food insecurity. The differences between a scenario, SSP1, where the world aims for sustainable development. It goes back to the Sustainable Development Goals, where the world really tries to achieve those Sustainable Development Goals. And you can see in that world, there will be challenges to food insecurity. It's not going to be easy. There's a lot that needs to be done. And there's a lot that we can do to reduce food insecurity. But if we're in a world with high challenges to adaptation, high challenges to mitigation, a world that breaks into large world regions, then you can see that the risks for food insecurity are much, much greater. They come much sooner in time and are going to be much more difficult to manage. And this is part of the underpinning of a very strong movement to say we have to focus not just on climate, we've got to focus on all of our choices. Because our choices for all of the sustainable development goals are going to interact, and they're going to make our lives more difficult or easier going into a very different future. And then finally, I just published this. These are burning embers for health. You can see there's heat-related morbidity and mortality. Across the top, ozone, malaria. Across the bottom, diseases like dengue fever, Lyme disease, West Nile. In this case, I've got 3 development scenarios. The one on the left is where the world breaks into large world regions. There's a high degree of conflict. The one on the right is where the world does aim to sustainable development. And the one in the middle is where the world just kind of muddles through. We continue our current trends. We try to make some things work. We get some things right. We get them right eventually. Sometimes we don't get them right, but we just continue our current patterns. And so these kinds of synthesis figures are being used, as I said, to help inform policy, to not just have reports that are lots of words, but to have graphics that people can really understand that we have to reduce our emissions and we have to really focus on our choices to ensure that we move to a world that is developing in a way that's resilient and sustainable. I think that's my last slide. And I look forward to questions on that.
It just, my impact, it seems sobering that there's not always much difference between SSP1 and SSP3. There's not as big a gap change potential as, am I reading that right?
Certainly for health, that's true. If you think of the ones I showed for food insecurity, for example, there's a much bigger difference.
Okay.
So it's all of the health risks of a changing climate are current problems. And we saw very clearly in COVID how weak our health systems are. And there's lots that we can do to really improve our health systems so that the risks are lower in the future. But mosquitoes going to change their geographic range. It's really up to investments in our health systems to be able to track those changes and to make sure that we take the actions that we need so that we protect health. And as we understand better the effectiveness of actions that are taken, then I think we'll see a bigger difference across the 3 for the burning embers for health.
Mm-hmm.
Good question. Thank you. George?
Actually, our picture is kind of reversed. I'm Harold. She's Georgianne.
Oh, sorry. It's my mistake.
I just want to make sure I understand. We used to think that things would get bad if the temperature increased by 7 degrees. And now we've already changed 1.5 degrees, and we realize that another 0.5 degree is really, really bad. Is that correct?
It's very, very close. The world has warmed 1 degree.
Oh, okay.
And the reason that there was this special report on warming of 1.5 degrees is the government focal points are super knowledgeable in this area. And they understand that mitigating to 2 degrees is different than mitigating to 1.5 degrees. And they called for this report. It's the first special report they've ever called for. And they called for this report to say, what does it matter in terms of human health, well-being, prosperity, ecosystems, agriculture, water resources, if we significantly reduce our emissions down to 1.5? Because we know it's going to cost more. what do we get for that? And so this report said, at 2 degrees, our risks are really high, and you can have a really significant difference to get our emissions down so that we stay under 1.5 degrees. And that's why the burning embers were such a useful way to communicate that, because you could see the difference between 1.5 and 2 degrees. And then economists like to count things. You can start counting how many people then would be affected. What would it mean for food security? And those figures are continuing to be refined, and there'll be even more figures coming out when the AR6 comes out next year. But exactly right. That used to be we could warm to 7 degrees, and now people are saying we don't know even about warming to 2 degrees.
I was wondering how these predictions or anticipations, rather, how do they take into account, if at all, sudden changes that are occasioned by climate change? So, for example, I heard recently that there are some predicting that the rainforests in South America will, by somewhere in the 2030s, will be emitting CO2 rather than absorbing it, or with entire glaciers melting and the changes that come with that. So how do these, which seem to be projecting gradual change, anticipate sudden change?
That's a really good question, and there's lots of answers to that. One answer is, again, we're looking to the future, so we use scenarios. And it's pretty sobering when you look back. We went through the 2008, 2009 economic decline, and it made almost no difference in our emissions. That we've seen big changes throughout the last century. You look at World War II, if you look at the track of greenhouse gas emissions, and there's huge events on our time scale, human time scales. World War II, the big economic recession, other big events, and really hasn't affected our greenhouse gas emissions very much. And so we have a lot we need to do. The good news is we've got the tools in the toolkit to be able to do it, so we can bring down our emissions. But given that, there's lots of unknowns. That we don't know exactly how the whole climate system, and the climate system includes oceans, includes the ice, includes the atmosphere, includes the land. And we don't know exactly what's going to happen as we continue to put more greenhouse gases into that system. And we don't know what's going to happen if suddenly we start getting methane release from the Arctic. And so there are lots of unknowns. And frankly, that's the argument that we've all been using for quite some time. You'll hear from deniers that there's a lot of uncertainty, so we shouldn't do anything. On the other hand, there's a lot of uncertainty, and we may be optimistic about what could happen. The example I typically use is, who knows when their next auto accident's going to be? Who's got auto insurance, right? We insure against things that we don't want to have happen, but we know could happen. And so the science tells us there's a lot that could be happening. And we don't know enough. And unfortunately, some of the issues that are important, like melting of the West Antarctic ice sheet, we're probably not going to know until 50 years after that process is underway. That it's going to take a long time once that irreversibility has kicked in for us to be able to detect it. So the uncertainty is a call for more action. Lisa says, dealing with climate change instead of prevention, we have to do both. There's no question we have to do both. That the climate system has a lot of inertia. And all of the greenhouse gases up in the climate right now will continue to drive climate change for 30 years. And just look at all the extreme events we've seen around the world. When we look at NOAA, the National Oceanographic and Atmospheric Administration, every year counts billion-dollar disasters. It's not the million-dollar disasters. It's not the flooding that was down the street that affected your house or affected your ability to access grocery stores, access care, just the billion-dollar disasters. And the US last year had 20-some billion-dollar disasters. I'd have to look the numbers up. And I think the total amount for just the billion-dollar disasters was over $63 billion in 1 year. If we don't do something about climate change, we can't afford what's going to happen. We're not going to be able to afford the extreme events. And so it's prudent to make those investments now. Susan's got a good question on the city of Seattle, potential for flooding. I know there's a lot that the Seattle Public Utilities have been doing. I don't know exactly what they're doing. They've had a group working on climate change for 15 years, I think. And so there's quite a lot that they're thinking about. And it's not just the flooding in South Seattle. When you think about Seattle, much of our drinking water comes from snowfall, from the melting of snow. And as we continue to warm, we're going to have less snowfall and more rainfall. But our reservoirs weren't designed for that. And how do you modify the reservoirs so that you capture that rainfall so that we can have the water that we're so used to having? And how do we protect the city? And how do we think about what we need to do in terms of our infrastructure? I don't know how many of you have driven downtown when we've got high tide and are having a heavy rainstorm. But as you drive around downtown, you'll see water spouts coming up out of sewer systems. And that's because with high tide, the pressure of Puget Sound blocks the outlet for the outflow of water. And the water's got to go somewhere. So apparently there's even buildings downtown that get water spouts during heavy storms when we've got high tide. So there's a lot we need to change in terms of our infrastructure. Bob, what's the opposition to the work of the IPCC? Vested interest primarily. You know, there's a number of companies that would like to ensure that we keep burning as much fossil fuel as we can. There's a huge shift going underway in terms of moving to electric vehicles. We're really fortunate here in the state of Washington because we've got hydropower. But you know, there's people who'd like to keep selling products. They'd like to keep things as they are. Not that dissimilar from the tobacco industry and how the tobacco industry fought so hard against having any kind of warning labels. So, vested interests. There's some other questions.
So which part are you working on then for the next report? The next report comes out in 2022, is that right?
Correct. I'm in working group 2 on impacts and adaptation. And I'm specifically on the human health chapter.
Okay.
And it's in working group 2, most chapters have about 10 or so authors. And there are, how many chapters there are this time? 15 chapters, something like that. So it's not a big group of people. We do have contributing authors. We really rely on getting scientists to volunteer to write a couple of pages on a topic. But overall, it's, not more than 1,000 people who put together each one of the working group 1, working group 2, working group 3 report.
So that included like the malaria, the dengue fever, those things. Okay, thanks.
Yeah.
Did you discuss it all, and I missed it, climate migration? I think that's an issue that's going to really affect the United States and particularly the Pacific Northwest, because we seem to be the one little corner that has, isn't blaring red on the temperature predictions for the future of the United States.
Migration is a very complicated issue. By and large, most people don't want to migrate. They want to stay in their homes. They want to stay with their family and friends. And when you look at the drivers of migration in many countries, including to some extent in the United States, we've got a lot of seasonal migration. We've got a lot of seasonal workers that come in, but they go back home, right? And so trying to disentangle why you have migration is really complicated. There's a large World Bank report a couple of years and pointed out that the really poor can't afford to migrate. It costs money to migrate. So the poor are stuck in place. And there's quite a large number of people around the world who are on the borderline of poverty. And it doesn't take much to, if they get themselves above the poverty line, to get pushed back below the poverty line. And those are populations that will try to migrate if they can. And there's lots of efforts as part of the SDGs, the Sustainable Development Goals, and other UN organizations to say there's better ways to helping people live where they want to live. So there was an effort a couple of years ago from an international agricultural research group to raise $1 billion to develop new kinds of seeds that are more drought and heat resistant. So they can continue to farm where they are, which is frankly what they'd really like to do. And so it's finding economic opportunity for people. A lot of the people who are coming to the US borders don't have economic opportunities in their countries. And are there ways to help those countries develop their economic opportunities and help them put in whatever infrastructure they need to protect their cities so that they can stay where they want to live? And making those investments mean that we wouldn't have to have those discussions about what could happen with migration.
It looks like we're just at about time. I was wondering if I could ask one final question. And of course, we look forward to you joining us again on June 6th. And for those, again, who joined us a bit late, this will be available on our YouTube channel. So please, if you would like, go and go there and encourage others to do the same. This can get really overwhelming really fast and discouraging. I'm curious, you mentioned at one point how we have the tools, and that's so good to hear. Where else do you find encouragement as you address this problem?
First of all, I work with an amazing group of scientific colleagues who are just incredibly dedicated. The second is there is so much change going on. Before COVID, I sat on an airplane out of Seattle next to somebody who worked at a company here that does work for Boeing and was talking about electric airplanes. People are enthusiastic. They're really working on making changes. Industry doesn't want to really talk much about their changes because, it gives advantage for them to not share all of their secrets with their competitors. I get encouragement. The students are super enthusiastic about this issue. Students are impassioned. My classes get bigger and bigger every year. Students want to work on this. One thing I was going to mention next time, I'll do it now. If you're interested, every other year, King County has the Green Globe Awards. And the last was, I guess we're due for another one this year. I think it's this year. Anyway, if you go to the Green Globe Awards, there were a dozen awards given. And it was to groups that are cleaning up rivers. It was to individuals that are making a real difference. There are thousands of opportunities to go and work with people who are similarly concerned. And that really makes a difference because you are doing something to help manage this. And the last point I would make on that is there are surveys that come out every year about the opinions of the American public about climate change. And the last one said 2/3 of Americans know that the climate is changing. More than half want to see policy. More than half want to see something done. And I can go through and give you more details on it. But the most telling question was, have you talked with anybody about what you think about climate change? And Americans don't. About a third of the American public talks with anyone else about climate change. People are worried about it. People read what's going on in the newspaper. They're deeply concerned, and they're not sharing it. The joke I like to tell when I give some of my talks is, if we've got 2/3 of the American public that wants to really have action on climate change, really move on climate change, you know, the rest of the public is in Congress, and they're the ones who are not really moving forward on the progress. The more we talk about it, the more we're going to have the political will that we can make a difference and have the policies that we need and make this transition where we're going to have jobs that are going to be really desirable jobs. We're going to see shifts in, I guess, in interesting ways. Everybody, not everybody, but many people are worried that the future is going to be somehow different and scary. As you can imagine, I have an electric vehicle. It doesn't look that much different than a Model T Ford. You know, the styling has changed a bit since then. That's the Model Ts were made out of cast iron. They're indestructible. My car is probably better protected from airbags and everything else, but it looks the same, right? There's lots going to change, and a lot's just going to basically look like it is today.
Well, thank you so much for joining us. This was fascinating. I should share with everyone that Dr. Ebi has once again invited us to give to charity the honorarium that she would be paid. So for both sessions, that money will go once more to Earth Ministry. So on behalf of them and on behalf of us, thank you so much for being with us today. We look forward to you joining us again on June 6th.
Thanks so much, everybody. Appreciate the interest.
Thank you.
Thank you.
Thank you.